Hey everybody, and welcome to this demonstration of Dremio, the Unified Lakehouse Analytics Platform. A platform that aims to make data lakehouse architecture easy, open, and fast by providing you with unified analytics to combine all your data sources, such as object storage or on-prem data lakes, and other data sources in your long tail of analytical sources such as relational databases, NoSQL databases, data warehouses, and more, and being able to combine them all through Dremio's universal semantic layer, where you can govern it and make sure you maintain top-level security. But not only can you curate the data, but you can query that data with a SQL query engine that has top price performance, allowing you to use unique features to Dremio, such as reflections to accelerate those queries, allows you to federate those queries, and again, allows you to operate across multiple clouds and hybrid cloud and on-prem environments. But oftentimes, the center of your analytical world will be your data lake as you build a data lakehouse. So being able to manage that lakehouse so that way it just works is a big part of what Dremio brings to the table with its lakehouse management features, providing you a modern data catalog with Git for data features along with automatic table optimization. So that way those tables are always crisp, always fast when they're queried. And again, this platform can be brought to you either through a self-managed Kubernetes deployment or through a cloud-managed SaaS deployment. So again, Dremio allows you to shift left, so it allows you to kind of move more and more of your workloads from the extra storage cost, the extra compute cost, the extra egress cost of having to work more in a data warehouse and be able to, again, shift left so that way you're doing more of your workloads on the data lake. Okay, so that way Dremio is able to make the center of your analytical world your data lake, because you'll be able to connect your data sources directly to Dremio and then deliver that directly to your analysts, data scientists, etc. Because Dremio provides you that intuitive self-service experience, that intelligent and powerful query engine, and those next generation data ops capabilities with its integrated catalog, those Git-like features, table optimization, and more. So now let's begin with the demonstration. Hello and welcome to this demonstration of the Dremio Unified Analytics Platform. In this demonstration, we're going to assume that I'm a data engineer and I'm getting different types of data requests from data analysts and data scientists on basically curating our data platform. So you can see here several different requests that I am receiving in my backlog that I would like to, well, kind of see in that completed column. So what we're going to do is we're going to go through each of these one by one and kind of demonstrate the powers of the Dremio cloud platform in making life easier for your data engineers, your data analysts, and data scientists as we go. So basically what's going to happen is that first let's go over to our Dremio platform. So when you're taking a look at the Dremio platform, bottom line is you're going to have your default catalog, which is generally where you're going to curate your semantic layer right over here. Here you can have any additional catalogs, any connections to object storage, databases, data warehouses, all curated, which you can add easily by just clicking Add Source to see the variety of different sources that you can connect to. Okay, but we're going to be working today is I'm going to be curating some work out of here in this catalog. In our Arctic catalog, we have our demos catalog. And in here, I'm going to have our Feb get started. And here we're going to be doing some work. And as you can see here, what I have is a departments and employees table. Okay, that we're going to want to work with, but we have some requests regarding this raw data. So again, this is the raw data. Whenever you see purple tables, those are raw data tables, not, as we'll see later on, views, which are not copies. They are just logical views on that data, so you're reducing your total storage input by not making copies in Dremio's no copy architecture. So the first request that I'm getting is to create a view of employees and the departments they work for. Okay, so probably the first step I'm going to want to do in that, so if I take a look at this, I've broken it down to several steps that I'm going to do. I'm going to create a view joining the employees and departments because I need to kind of have that all sort of in one view. But at the end of the day, after I create that, I'm going to create another view that only shows me the employee and their department. So how would I go about that? Well, fortunately, I do a cool feature of Dremio is that you're able to save scripts with SQL. So in here, I have a script that already kind of does the join part of this. Okay, so that I have right here. Okay, and what I can do is I can just set this to the right context to where that table is. Okay, so I'm going to sit here and say, hey, Feb, get started. Okay, and what's going to do is it's going to create a view called raw department employees that is a join of those two tables. Okay, so now I can just run that query. Okay, and a couple things to notice is notice how it gets this tab, so you can actually run multiple queries in the same window, and each one will get its own tab. Two, I can actually have multiple query engine tabs, so that we can actually have completely different workspaces working on different queries and different data sets at the same time, making this a really robust and easy to use SQL editor. But as you can see there, I've created the view. Okay, so now what I can do is I'm going to head back over here and take a look at demos 2024. Feb get started. Okay, and see now I've created a view. So notice how the icon is green. This means this is a view. So this is not a copy of the data. So technically the only physical data that I have stored currently are these two data sets right here. And this just allows me to provide a view that I can then grant access to my data analyst who needs this data. Okay, but really they don't want this. They want just the name and the department. Okay, but just to show you that when I run a query on this, I get the joined data. But really that's not what the analyst wanted. They wanted, just first name, last name, and department, really just the department name. So if I look over here at the columns, that's going to be this name column right here. Okay, and we just rename that as department. So now what I'm going to do is I'm going to run that query just to make sure that it gives me the output that I expect. Okay, and I see, there we go, 3 columns. So that looks like the view that my analyst requested. So what I can do now is I can just click Save As View, and this can also be done with SQL, which again, SQL can then be sent not only through the Dremio UI, but through JDBC ODBC, through Dremio's REST API, and Apache Aerofly, allowing a lot of the aspects of Dremio to be automated by external code if you wish. So now I can save this view. Okay, and again, I can save it where I want it. So here in the demos folder, here in 2024, under Feb Get Started. Okay, and we'll call this like raw. We'll call this name and department. Okay, I will save that. Okay, and then that will complete that. So now I can go back to over here to kind of see the results. So if I head over back to demos, okay, 2024, Feb Get Started. Okay, and then we see the name and department view. And again, I can then grant access to that user. So I can click over here under settings, okay, and see where it says privileges. I can then grant this access to this view to a user of my choice, and then actually choose their level of access to that view or to that table. So I get really fine-grained access. On top of it, you have built-in column and row access rules, so you can actually do very, very granular access to make sure that your users only see what they're supposed to have access to. Okay, cool. So we created that view. Okay, so we've satisfied this ticket. I've created the view I created the join, and we created the view with name and department. Wonderful. Okay, so that means this ticket, which we have been working on, is now completed. So now let's bring over the next ticket. Okay, so in this next ticket, what we're going to do is it turns out that analyst wasn't happy with the view we created. They didn't want a separate first name and last name field. They really wanted a single field. So now they filed a ticket requesting that field. Now, normally using other systems, this would require me, the data engineer, to go back and change the creation of the view in order for me to be able to provide this for them. But luckily with Dremio is very self-service. So the analyst can actually deliver this for themselves. So if I'm the analyst, I can just log into my account where I have access to this name and department view. Okay. And then I can then make the changes necessary to get the view that I really wanted. Okay. So I can say, hey, I want first name. Okay. And actually, to make this even easier, what I can do is I can use the text to SQL feature over here. So what I can do, so I grab this field here, and I'm just going to go grab the data set that I want to do this on. Okay, so that's going to be under demos 2024. Feb Get Started. Here is the name and department table or view. I put that right there and say, hey, I want the first name and last name field to be a single field called full name. And in this view, also include the department field. Okay, so I can click generate, and it's going to generate the SQL for me to do that. And let's see, here I have exactly that. So now I can copy this SQL. Okay, or I can just insert it. Okay, and see, it'll do that for me. I like to always kind of get rid of some of this extra white space there. But yeah, so then I can run this to see if this gives me the result that I want. Okay, name, department. Oh, okay, so I have to set the context. Because see, right now, see, it's saying name department. So right now, since I have no context set, it's going to expect the fully qualified name. So I have to give like demos.2024.feb get started. I could do that, but the beauty of the Dremio engine, to make life a lot easier, I can click here on the context, and I can actually just set the context to exactly where I expect this table to be, which is right here. And now that that's set, and notice these errors are pretty self-explanatory. So I can see, hey, it's not finding where it's looking for it. And now I can kind of go back and adjust and then run my query again. Okay. So good errors makes for good troubleshooting. So now I see that I have the results that I want. That's the view that I want. So I, as the data analyst, can now just go save that as a view for myself. Okay. And say, hey, I want that particular view, and say, full name, department. Save that back in that same folder. So demos, Feb 2024, Feb get started. Okay. And hit save. Okay. And now that view is going to be available in that folder. So if I go over there, and there it is, full name department. So yay, I have fixed it. Okay, so there we go. I can say, hey, you know what? I have made a full name field, and now, and again, this time the data engineer didn't have to do it. That's the beauty of this aspect of it, the self-service aspect of Dremio, where there's going to be a lot of times where the data analyst or data scientist will just be able to kind of handle many of these requests themselves with the data that you've given them access to, instead of constantly having to go back and wait weeks sometimes for data requests to the data engineer, who already has a huge backlog of requests coming in. So the next thing we want to do is that we want to update that original view, because they realize they would also like the budget column in that view. So that is going to require the data engineer. Okay, so first let me just move this over to completed, move this over here. And essentially what we're going to do is we're going to update the view that we already created, okay, and make sure that it includes that view. Okay, so let me just close out some of these extra tabs. So what I'm going to do is I want to update this name department view. Okay, so I'm going to click on this pen, so that way I'm in sort of edit mode. Okay, so see here it's showing me the original SQL. Okay, instead of just showing me the view namespace. So this is going to allow me to update that view. Okay, so now I can go in here and just say, hey, I want to add, budget. Okay, and then what I can do is I can just pop this out just so that way I can make sure I can see the any information that I want here, because usually I can see the different columns here. Okay, but let's just see here if I type in budget. Okay, and let's just run the query, see if it gets me the result that I wanted. Okay, and I see here, first name, last name, department is showing up as a number. Okay, so the reason is, same mistake I've done before, is that this should be name as department, and then I need to add another comma to here for budget. So you see, that's why I run the query first. I can just confirm that I did it quickly, do a quick visual validation, and then I can go back and correct, doing a lot of this stuff a lot easier versus finding out that you made a mistake way down the line. And there we go. Name as department. Although I see I have a name and department field, I should only be seeing one. So I'm examining a first name, last name. Oh, I see I have name twice. So let me go take out name there. Okay. And let's run that again. And there we go. Okay, so there's the view that I want. And now I can just click Save View. Okay, now I've just made a new save to the view. And again, these views are not copies, so nowhere have I duplicated data up to this point. Okay, but now I'm creating assets that people can view to see the data as they need to see it, and only the data they need to see. But another really cool thing about Dremio is that since I'm using the Dremio catalogs, okay, what I can do, currently called Arctic catalogs, okay, I can go into this catalog and I can actually see all the commits. So if I go over here, every change is a commit to the catalog. So I can see, hey, look, there was that alter view statement done 30 seconds ago. That was me updating the view. Okay, and I can see when I created these views, and I can see, hey, who did it. This gives me a very high level of observability into what's going on in my catalog, what changes are being made, who is making those changes. But it also gives me the ability to roll back to any of these commits. So just like Git, if something goes wrong, I can roll back to a commit where things were good. I can create tags, so that way I can tag particular commits that I want to be able to easily replicate. So I can say, hey, I want to tag I want to be able to scan or do a query at the catalog as it was at that point in time. Okay, and I can create branches to like isolate work, which we'll be showing you shortly. Okay, but going back over here, we did that. We updated the view to include the budget. Wonderful. And next, what we're going to do is we're going to be ingesting some new data into the employees and department table. Okay, so actually first let me move this to completed. Okay, and then we're going to move this over here to show you ingesting new data into the employees and department table. So what steps am I going to take? Well, one thing I'm going to do is I'm going to take advantage of those Git-like features, because I don't want to accidentally ingest the data and then there's a mistake with it, and now I'm having to pluck out the bad records, do backfilling, all that tedious work, and also affect production queries. What I'm going to want to do is isolate that work from my production branch, the main branch, and get it done. Okay, so I'm going to create a branch to isolate the changes, do all the work on that branch. Then I would theoretically validate changes, whether I run any queries that will just double check to make sure that there's nothing wrong. And then once all those queries have ran successfully and I'm happy with my results and I'm happy with the changes, I can then merge those changes in there. And again, while I'm going to do all this in the UI, again, this is all done through SQL. And like anything that's SQL in Dremio, it could be automated using external programming scripts that connect via JDBC, ODBC, our REST API, or via Apache Arrow Flight. Okay, so it's all very, very flexible. So now let's go do it. Okay, so in this case, let me go back to our query engine. And basically, I have a script for just this particular purpose. Okay, so right here. So here's the script. Let me just make sure I set the context to the folder we're working out of today, which is this Feb Get Started folder. Okay, so there's my context set. So basically, if I were to walk through this, as you see here, okay, I'm going to first create the tables as they are, just to show you that, hey, let's just see how many records are in the table before we do anything. Okay, then we're going to create and switch to another branch, which you can see is very simple SQL. Okay, so taking advantage of this feature is actually pretty easy. I will then ingest the new records into the respective tables. We'll then query the count of the table, so you can see that on this new branch, okay, there is going to be the new data. And on that note, I want to make sure that we use a unique new branch name. So I'm going to call this Feb19. Okay, and I'm just going to change that everywhere in this script where we refer to the branch. So that way I'm not using a branch that already exists. The idea is you create a new branch to isolate those particular set of changes. Okay, so again, I'm creating the branch and then switching to that branch, ingesting the data. Then we're going to count the record so you can see that the data has changed. Then we're going to switch back to the main branch, query the main branch so you can see that the main branch has not changed, so that the count should still be the same. Then we will merge the changes, query the main branch again so you can see that now the counts reflect the new data. Okay, and so theoretically, before we do that merge, that's when you would do your validations, whether you're using like DBT, Monte Carlo, Great Expectations, whatever your preferred way of validating your data is, or using sort of your own queries against like your own business rules tables or constraint tables that you're checking. Okay, so with that, I'm going to go right over here and we're going to run this query and let this run. And again, so notice how many queries I have just running right here in this one editor. Okay, so again, I have that editor in this tab, and then again, each query down here is getting its own tab. Okay, making it really easy to get a lot of work done very quickly. And I can actually start already seeing the results of queries that have completed. So I can see that original query that queries the tables, that we see a count of 5 in the departments table and a count of 10 in the employees table. So that's before we make any changes. So I go to query 3. Okay, I create a branch, so I can confirm that the branch has been created. Okay, I can then see query number 4. Okay, that we have switched over to that Feb 19 branch. Okay, then I can see that we're now from that branch, I've inserted 5 records into departments, and notice how it highlights the query that I'm referring to as I do it. So if I click on query 6, see, it's going to go highlight over here because that's the query that this particular tab corresponds to. So here I injected another 5 records into employees. Okay, so now when I query the ETL branch, I'll see that now departments has 10 records versus the 5 it had before, and employees has 15 records versus the 10 that it had before. Okay, now I'm going to switch back to the main branch. Okay, so right here we switched back to the main branch, so that switches our context. And then what I'm doing is I'm going to query tables on the main branch before the merge. So we see, notice that we have still 5 records. So again, my main branch, my production data has not changed. It's still only 5 records and only going to be 10 records for the employees table. So that's the beauty of this. We've isolated the changes. The changes are not being hit in our production queries. But once I do the merge, okay, and we can see here that the merge has been confirmed, I can then see that now when I query the main branch, I do see the additional records, 10 and 15. Okay, so I can isolate my changes. I can create branches for experimental purposes. There's a lot of use cases for this particular form. It can be very, very powerful. We've seen customers who've used a pattern of basically creating a branch for every day. So at the beginning of each day, they create a branch. Then all the ingestion work throughout the day is done on that branch, validated at the end of the day, and then merge into their mainline production data set at the end if all validations have passed and the data has been cleaned up. Okay, making it really easy for them to assure that that mainline production branch is always in top quality. So we've completed that. So again, we created that branch, we ingested the data, validations can occur at that point, and then we merge the data back in. Easy peasy. Okay, now one last ticket I get is I have a ticket from a data analyst, data user who is building a BI dashboard. And the problem is they need to improve the performance of the BI dashboard on that weather data. Okay, on weather data. So let's take a look. Okay, so if I go take a look for that weather data set, should be here again in our trusty folder, 2024, Feb get started. Okay, and we see this weather data set. So theoretically, we have a user who's building a BI dashboard on this. Now, usually BI dashboards are usually the result of a lot of aggregations, so using group by statements, sum, counts, all these kinds of things. So what I want to do is that I want to make this faster. So Dremio has a very unique feature called reflections. And I can, by clicking here where I say edit dataset, it's going to take me to this screen where, again, I can see the original table if it was the original query if it was a view, but I can also see the section called reflections. Okay, and now notice there's 2 types of reflections. There are raw reflections and aggregate reflections. So raw reflections essentially replaces the need for materialized views. Okay, so anytime you need to speed up the query on raw rows of the table, okay, you can just use raw reflections instead. Okay, you would just turn it on. Okay, so I'll just quickly show you. So I can turn on raw reflections, and then I can even tailor these raw reflections to, only materialize certain columns, to sort based on certain columns or partition based on certain columns, and I can actually create multiple reflections. So typically what you do is you'd create multiple materialized views for different query patterns, and users would have to kind of know which one to query. Here, you create the reflections and Dremio does the figuring out for you. It'll say, okay, hey, I have these 5 reflections for your query. This one's going to make the most sense for making to complete your query the fastest on this particular table. So instead of taking one table and turning it into 5 additional namespaces, you just have one namespace. Users are just going to notice that their queries are faster. Okay. So now if I go back to reflections, okay, then we have our aggregate reflections. This is going to be more important for like BI dashboards. So again, in this situation, we have a user who's building a BI dashboard on the weather column. So theoretically, what I can do is I can turn on aggregation reflections, choose which dimensions, okay, they are optimizing for, which measures they're optimizing for. Okay, so maybe where they're measuring like precipitation and snowfall based on station and name. Okay, so then what I can do is, again, those are the types of queries they're doing on their dashboard. And then what I'm going to do is I'll hit save. And what's going to do, it's going to create a materialization, a pre-computed version of those results. But instead, the user doesn't have to really worry about this. They're just going to notice that their BI dashboard is just much faster, sub-second queries, okay, because all those results are pre-computed. Okay, but Dremio is going to handle, again, the swapping out of knowing when to use these materializations, and two, updating these materializations on a cadence. Okay, so that you can also manually trigger via REST API and soon SQL. So bottom line, it gives you a really easy way for me to accelerate, because oftentimes building a BI cube or extract would be much harder than just flipping a switch like I just did. On top of it would require a lot more maintenance work, manual maintenance work on behalf of the data engineer. So now I'm getting those same benefits at the flip of a switch. And same thing for like materialized views with raw reflections. Okay, and all these things make the Dremio platform much, much easier. And again, just a couple of other things I'd like to point out is that when you're using Dremio Cloud, again, you also get this jobs page that makes it really easy to monitor all the jobs coming into your Dremio cluster to see sort of who's running what queries and how are they performing and seeing their breakdowns. On top of that, you have this engine section where you can control the compute that you make available to your users. So you can have different engines of different sizes, and you can use engine routing to make sure that you're routing workloads to the engines that that you want. So for example, I might have high priority workloads and that I want to make sure go to particular engines that will execute them faster, and I maybe have lower priority workloads that don't need to use the expensive compute. Okay, so I have very flexible control to make sure that I'm scaling and managing my workloads in a way that's going to get me the performance that I need without breaking the buck. Okay, because the engines can scale up and scale down based on the rules that you set. So you have a lot of flexibility as a data engineer to build what you need, but it's also easy to do and really kind of unifies all your data, because again, you're connecting all your data across databases, data lakes, and data warehouses. So hopefully you guys enjoyed this tour of the Dremio Unified Lakehouse Analytics Platform. I'll see you all later, and ciao.